Hello everyone. Today we will see the optical recording and its related fundamentals in today's session. So we'll start with the classification of recording technique. Okay, so recording can be classified in two forms. Number one, a magnetic recording, and another is an optical recording. Magnetic recording is divided into two parts: tape recording, magnetic tape recording, and another is disc recording. So tape, you are aware of audio cassettes, video cassette recording, camcorders, in which video tapes, okay, a PVC material over which a ferromagnetic material is laid, and the construction is in a such a way that magnetizing and demagnetizing of that ferromagnetic material pasted on that PVC material is going to store the information. So that information may be analog or digital in a nature. So likewise, this magnetic tape recording is possible. Magnetic tape recording, another type is disc recording, that you are aware of floppy disk, hard disk. Nowadays also, if you are going in a market to purchase 500 GB or 1 TB or 2 TB hard disk, they always ask you whether you want magnetic hard disk or whether you want flash type of disk. Flash type of disk, they are 10 to 15 times costlier compared to hard disk. That is not a part of discussion right now here. So right now I'm talking about magnetic recording, tape recording, and disc recording. In disc recording, you may have a floppy disk recording or hard disk recording. Now second type of recording is optical recording. So as far as your audio video engineering syllabus is concerned, you have optical recording in your syllabus. You don't have magnetic recording right now in your syllabus. So we'll discuss this optical recording. Optical recording, again, it is classified in two forms: photographic film recording. We used to have such type of recording in studios almost 25 to 30 years back, but nobody is using this type of optical recording nowadays. But since the optical fundamentals are used for recording the data or information, that's why it is coming under the optical recording, that is photographic film recording. Nobody is using nowadays. Second type of thing is optical disc recording. This is being used nowadays everywhere. So it may be audio CD, VCD, DVD, high definition DVD, or Blu-ray disc DVD. In such type of uh, optical disc, these optical recording fundamentals are used. Now, optical recording, just now I told you that optical disc recording may be on audio CD, it may be a VCD, DVD, HD DVD, Blu-ray disc DVD. Audio CD, you go up to 700 MB. Then DVD, you can go the recording capacity up to 4.7 GB of single-sided, double-sided. Both the versions are available. High definition DVD, you go up to 30 GB recording, and Blu-ray disc, you go up to 60 GB recording. One side, two side, both the options are available. Now, if you consider a simple optical disc or playback of optical disc, then basically the different layers of optical disc are shown in figure. So if you see, the front view of that is given, or it looks like this, and this is what the side view. So if you see it carefully, okay, so I'll just show you such type of thing. This is front side and this is back side. Okay, front side and back side. So let us see what is there between front and back. Okay, so this is front side and this is back side. So upper side or lower side. So the upper side is a label side of CD. Okay, and the lower side or the lower portion is known as playing surface of CD. This is what the side view. Upper side, lower side, and this is the side view. Now we will see the different layers. So basically four different layers are there. The uppermost layer indicates the label. Thereafter, photoresistive material comes into picture. Then aluminum oxide reflective coating comes into picture. And finally, the lowermost side is transparent polycarbonate plastic material is there. So this is what the side view of your any optical disc. The most important part in this optical disc where the data is recorded. Okay, optical recording always use digital data. Analog data is not allowed. See, we have already discussed that in this classification. Okay, whether it is audio cassette, video cassette, camcorders, there is analog and digital data. Both the things can be recorded, but in optical recording there is no option of recording analog data. So analog data is always converted into digital. It is digitized, compressed, and thereafter it is given to a high intensity laser which burns the information. In this, photoresistive material is burned with the help of high intensity laser, and accordingly the information is written in bits or land. Such type of information we will see how the information is read, how the information is written and read from this optical disc. So all of you give attention. So this is what the front side, okay, this is the top side, bottom side, and side view. So a basic optical disc, 4 layers. Label side, photoresistive material where exactly the data is burned or the data is available. And third is aluminum oxide reflective coating, and fourth is transparent polycarbonate material for the protection of that specific inner layers. Okay, so this is what the general construction and the description of different layers of optical disc. So this is front side, this is back side, or top side, back side. This is top side and this is back side. Now we will see a typical optical recording of audio signal, and then we will see the details of optical assembly of this CD player. Okay, now all of you your attention. This microphone is there. Let us say we will talk about audio recording only. So whenever you talk in front of this mic, compression and rarefaction of the air with the help of these transducers are converted into equivalent electrical signal of 20 Hz to 20 kilohertz. So it may be men's speech, women's speech, or musical instruments. They are being played at a back end along with men's speech and women's speech. So equivalent 20 Hz to 20 kilohertz signal is pre-amplified because the output of this microphone is less. So pre-amplified signal is A to D converted. That is what sampler and digitizer is there, and thereafter in which a multiplexer is used where the synchronization pulses, control word, and sync information is multiplexed. So actual data, audio information converted into digital data, and this control information, sync information, etc. for synchronization, and this multiplexed digitized data is given to the error detection and correction unit. So we are aware of, we have you have already studied this ITCC and subset in a third year. So there just try to recall source coding and channel encoding. In this channel encoding, this FEC, that is forward error correction, this type of coding techniques you have already studied. So that FEC is used for the error detection and correction. Thereafter, it is given to a laser beam which generate a high intensity laser, and the turntable is there to rotate this disc. So the CD is being rotated at a different speed. We'll see for inner track the speed is different, for outer track the speed is different, and this high intensity laser, okay, depending upon the incoming data, okay, this high intensity laser is going to burn the photoresistance material. Just now I told, explain you the construction of CD, and this high intensity laser is going to burn the photoresistance material, and the information is written digitally in the forms of ones and zero or bits and lines. Okay, so digital information is recorded. So this entire block diagram is indicating that digital recording, optical recording of audio signal only. Likewise, you can have a camera, convert this A to D conversion is done, then you add sync bits and control information, then you multiplex it and given to the error detection, then give it to high intensity laser beam, and you can burn the, or you can write the information these optical disc. So for simplicity I have just taken microphone. Here you can add the camera also, and the same block diagram blocks you can add final output, multiplex output. This audio and video multiplex output can be given to error detection and correction assembly. Then it is given to final laser assembly where high intensity laser, see why I'm saying high intensity laser, because you have to burn that photoresistance material. So you have to have a high intensity laser which will burn that photoresistance material. When there is a player, this is a recorder, this is CD recorder. Okay, that's why high intensity laser is required. But whenever you are talking about playback of CD, then you don't require high intensity laser. A normal intensity laser is required which reads the information, and accordingly for playback, that is CD player or DVD player, and the low intensity laser is used to recover the information which is written on the CD. Now you must have understood how typical optical recording takes place. Once again, I am telling you, audio signal is A to D converted. Sorry, audio information is converted into equivalent 20 hertz to 20 kilohertz signal. It is pre-amplified, then A to D converted, and it is multiplexed with the control information or sync information. This information is given to this error detection and correction block, where the FEC, that is forward error correction technique, is implemented. Then it is given to a high intensity laser beam which take that digital data and burns the information in the that photoresistance material which is available in that optical disc is burned. So the information is written digitally in the form of ones and zero, and this turntable motor is there to rotate the that specific CD at the specific rate that we will see in next slide. So just now I told you that analog information is converted into digital, and that digitized information along with control information is given to the high intensity later, and this data, digital data, is burned. So let us say this is the photo resistance material which is burned after applying this 1010, that is high intensity laser, on and off, and accordingly the exposed track of disk surface is shown over here. And that photoresistance material, before recording it was continuous, and after recording it is representing pits or bumps. So pits or bump, it indicates the edges, whereas it indicates the binary 1 information, and rest of the area represent binary 0 information. They are called as lands or flats. So pits or bump is nothing but the edges where this binary 1 is represented. So powerful laser beam burns the photoresistance material available on optical disc in the forms of bits and lines, that is ones and zeros. So likewise, this information is recorded on this optical disc. Now we will see optical disc, how it works. See this, the data is coming from this data error detection and correction device. This high intensity laser is there, and this CD is rotating with the help of turntable motor, and high intensity laser is coming through this semi-transparent mirror, collimation lens, objective lens, and this photoresistance material is burned, and finally the information is written in the forms of ones and zeros, and they are known as bits and lines. Okay, now the same assembly you can use it for optical playback, that is CD player, DVD player. In this, optical recording is not possible. Okay, so try to understand this thing. Player is different, recorder is different. So just now I told you the block diagram of a recorder, where this information is processed, given to high intensity laser beam, and the information is written in the form of ones and zeros or bits and lines. Okay, so now how exactly optical playback works? So that is very simple. The same intensity, this laser diode, okay, actually the laser diode with low intensity is used. It is going to fall on the same surface where the photoresistance material is burned in the form of pits and lands. So low intensity laser beam is going, and it is going to fall on that pits and lands, and from the edges the light is reflected back, collected with the help of this objective lens, collimated lens, and it is directed towards this lens structure to the photodiode array. This is basically a transducer or circuitry, okay, which is used to convert this optical information into equivalent audio signal, and this signal is taken, then D to A converted, amplified, power amplified, and it is given to the loudspeaker. So this is what audio optical recording and audio optical playback system normally used. Okay, now we will see what is this focus, vertical arrangement, tracking, lateral movement, and cylindrical lens when you understand the servo motor assembly in your optical disc recording and playback system. See this is the optical disc. Okay, please keep this in your mind. This is optical disc. Okay, so this is a turntable motor. So turntable motor, the speed is 500 rpm to 200 rpm. So if you are talking about the inner track, the track is small, information is small. That's why the rotation speed of that CD is going to be small. Now whenever you are talking about the upper or the outermost track, the track is bigger one. So the information content is bigger one, and hence that CD or DVD has to be rotated with a higher speed, and it is rotated at 200 rpm. So please keep this in your mind. The laser assembly on that optical assembly is going to move from 200 and move from inner track to outer track, and from whenever it is moving from inner track to outer track, the motor, which is known as turntable motor, it is rotating that CD at the rate of 200 rpm to 500 rpm from innermost track to outermost track. Now, so there are two types of motors which are available in CD mechanism. One is turntable motor, which is used to rotate the CD or DVD at the rate of 200 rpm to 500 rpm from inner track to outer track, whereas another motor is used to move the optical assembly. Which optical assembly? This optical assembly is moved from inner track to outer track. Okay, so that is called as servo motor. So servo motor is controlled by crystal oscillator clock and control circuitry. So there are two motors: turntable motor to rotate the CD from 200 rpm to 500 rpm or from inner track to outer track, whereas servo motor is used to move this entire optical assembly from inner track to outer track. Please keep this in your mind. Turntable motor is used to rotate the CD. Rotating of CD from 200 rpm to 500 rpm is done with the help of turntable motor, whereas servo motor is used to move this optical assembly from inner track to outer track to inner track, depending upon the track number which you are playing from that optical CD or DVD. So from that track, just now we have seen that whatever information the laser, low intensity laser, is going and falling on that pits and lines from edges that optical rays are coming, and it is collected with the help of photodiode array. The same photodiode array is connected to this optical assembly, where this optical information converted into equivalent electrical information, which is digital in nature. So digital information is converted into analog information, which is pre-amplified or amplified and given to the loudspeaker, and thus audio electrical signal is converted into sound signal. That is what the concept of audio CD, audio CD player system. Okay, so this is the general block diagram of optical decoder circuitry or block diagram of CD playback system. Okay, so from this discussion, you must have understood. In oral exam also, examiner may ask you what type of motors are being used in CD player or DVD player and what are their specifications. So you should be very much specific that two motors are there. One is called as turntable motor and another is called as servo motor. Turntable motor is there to rotate the CD or DVD at the rate of 200 rpm to 500 rpm, whereas servo motor moves the servo assembly on which this optical assembly is fitted from inner track to outer track, depending upon which type of track you want to play. And accordingly, whenever you select the different tracks, the servo assembly, maybe the inner side, maybe accessing the inner track of the CD or DVD, and it is moving towards the outer track of that CD or DVD. And after that, this optical information is taken and converted into equivalent electrical signal with the help of photodiode array. 4 to 5 different photodiodes are used to convert this optical or laser reflected light from that bits and lands and converted into equivalent electrical signal with the help of photodiode array assembly. And this converted electrical signal is a digital in nature, so it has to be converted into analog. So D2A conversion is done, pre-amplification is done, power amplification is done, and it is given to the loudspeaker, where this 28 to 20 kilohertz audio electrical signal is converted into sound output with the help of loudspeaker. Now, if you see the different specifications of the tracks, then immediately you will understand this thing. So what is it? Track 1, track 2, track 3, track 4. So if you consider the width of track, it is about 0.5 micrometer in CD. The distance between two track is 1.6 micrometer, and the rotation of disc. So this is the edges are normally representing pits, and remaining in area is known as lands. Okay, then this is what the different tracks information. Now if you see the CD reader optical specification or audio CD, where the maximum capacity of the CD recorded data is 700 MB. So standard wavelength is lambda 780 nanometer. Focal length plus minus 2 micrometer. Transducer photodiode array, which is used to convert optical signal into equivalent electrical signal, and pick up gallium arsenide laser beam. Low intensity gallium arsenide laser beam is used for reading the data which is recorded in photoresistance material in the form of ones and zeros. So please keep one thing in your mind, that optical recording, digital recording is nothing but optical recording. So any information, whether it is audio information or video information is taken, it is A to D converted, then it is um, synchronization control pulses are added, then it is given to error detection and correction mechanism, and when it is given to high intensity laser, optical recording is done. And when you are using that optical assembly with a low intensity laser, then that laser is going to reflect back from that photoresistance material, where the information is written in the form of ones and zero. Reflected information is going to fall on photodiode array. On photodiode array, it converts that information into electrical one. That electrical information is digital in nature. That information is converted into analog with the help of D2A converter. That analog information is pre-amplified, power amplified, and given to the loudspeaker, where this 20 Hz 20 kilohertz signal is converted into sound output. As I told you, the same thing can be used for video recording and multiplexed audio and video recording. So then you call it as DVD player. Only audio player, audio CD player is different. That only audio, microphone and loudspeaker is there. But whenever you are talking about television signal like audio and video, both the information is there, then normally you call it as a DVD or a video CD and all these things. Okay, so this is what the specification uh, this is what the specification of CD player, CD recording and playback. Just now I explained you, and accordingly